welcome to my English garden, and today we'll be talking about vectors. So a vector is pretty much anything that has a magnitude and a direction. So the way that looks like is like this. So this is our graph. This is an xy plane, and this is a vector. So the length of this line would be the magnitude. So we'll call that v for vector, magnitude of a vector. And the direction would be the angle, we'll call that theta, from the x line. So each vector needs to have a magnitude and a direction. They have to be straight lines. So something like this is not a vector. However, starting from here and ending from here, that could be a vector. All right. So let's talk about adding and subtracting vectors. The way you do it is you just put them tip to toe. That's how we call it. So if you have vector 1 and you want to add it to vector 2, the way you do that is you place this vector on the end of the previous one. So if it's from v1 plus v2, you start with v1 and then you add v2. In this case, it doesn't make a difference if you start from v2 and then put in v1. As you can see, we end up in the same position. This is going to equal vector 3, which is the same. You start at the beginning of the beginning, and you end at the end of both vectors, vector 3. Subtracting vectors works more or less the same. So if you have this vector as vector 1, and you want to subtract this vector, which is vector 2, the way you do it is pretty much the same, only that you are going to reverse the second vector. This one, because as you can see, it's a negative vector. So you start the same. You start from here, and you draw the vector opposite of how it's drawn. So it's from down up. So the way you draw it is from up down. This is vector 2. And vector 3 is from the beginning till the very end. Multiplication on vectors. So let's say you want to multiply vector 1 times 3. The way that looks like is exactly as you would imagine. If this is vector 1, you multiply that by 3, and it gives you 3 times v1. The same goes for division. If you want to divide v1 by 3, let's say this is your v1, well, you divide this by 3, and this is v1 divided by 3. So now, each vector, the way we draw them out, let's say, or the way we describe them mathematically, is we say that they have an x and y component. So the x component is how long on the x-axis they go, and the y component is how high on the y-axis they go. This is going to be Vx and Vy. This has an angle, of course. So this right here forms a right triangle, which is useful because we can find the distances of Vx and Vy if we know the magnitude of the vector and its direction. So using SOHCAHTOA, we can do this because this is just a triangle where the hypotenuse would be V and the other two sides would just be Vx and Vy. So assuming that we're going to use this angle here, sine of theta equals opposite over hypotenuse. The way this translates to this is the opposite of the angle is this side over here, and the hypotenuse is V. So sine of theta equals Vy over V. The same goes with cosine of theta equals adjacent over hypotenuse. Cosine theta equals the adjacent of the angle over the hypotenuse, Vx over V. Tangent works the exact same way. Tangent theta equals opposite over adjacent. So Vy over Vx. Like this, they're not very useful. However, if we want to find Vy, we can use this equation over here. By multiplying both sides by V, we get that Vy equals V sine theta. This is the most common equation used to find the y component of a vector. The same goes for cosine. If we multiply both sides by V, we get that Vx equals V cosine theta. Same rule applies. Most common equation used to find the x component of a vector. The tangent equation is actually used mostly to find what is theta. So the way we isolate theta is we multiply both sides by inverse tangent. So on this side, inverse tangent times tangent, it just disappears, and we have inverse tangent over on this side. So now we see how that works, because if we have the x and y components of a vector given to you by the problem, we can find its direction. So I'm going to leave that up there. Are there other things that we know from math, which is the other equation which is very common when you're doing vector calculations, is the Pythagorean theorem, which is just a triangle equation, which states that a squared plus b squared equals c squared. A and b being either one of the lines, and c is the hypotenuse. So if we want to just find c, then we do c equals the square root of a squared plus b squared. Now, as is not very exciting, so let's plug in our numbers. V equals, our vector annotations. V equals Vx squared plus Vy squared. Those are, I would say, the four equations that you would use most when you're calculating anything that has to do with a vector, its components, etc. I hope you enjoyed calculating vectors with My English Garden, and check out my other videos on physics for any more physics-related topics.